Superposition principle states that when two or more waves of light traveling in a medium superpose upon each other, then the resultant displacement at an instant is equal to the vector sum of the displacements due to individual waves. If y1, y2, y3 be the displacements due to different waves, then the resultant displacement is given by y equals to y1 plus y2 plus y3 and so on. It means we just add them up by using a simple arithmetic. Amplitude of a wave measures either the maximum height of the peaks or the depth of the troughs. Now we can see a ripple produced by a single source on water. It produces circular wavefront. If we add another source of wave, we start getting an interesting pattern. This pattern is created by the ripples from the two sources interacting with each other, where they meet up peaks with peaks and trough with troughs. The amplitude of the wave is increased. That is called a constructive interference. But if the peak from one wave meets up with the trough from the other, destructive interference is produced. Let us consider two cases. One is that the two waves will be in the same phase or in phase, and the other one is opposite phase or out phase. Here, let us consider one wave is like this, and another wave, let it be blue. They are in the same phase. In phase means maximum at the same time and minimum at the same time and zero at the same time. This is positive amplitude and this is negative amplitude. And in the second case, let this be one wave and another wave. They are in the opposite phase. Let it be smaller. Smaller amplitude. Okay. According to the principle of superposition theorem, superposition principle, let this be y1 and this be blue one is y1, the red one is y2, blue is y1, red is y2. According to superposition theorem, the resultant is y1 plus y2. Okay. Here they are in the same phase. The resultant y will be the algebraic sum of these two. If this is 5 and this is 8 units, let it be 5 cm, 8 cm. The resultant will be 5 plus 8, it will be 13. Here it will be 13. And again, minus 13. Like this. This is the resultant wave. It is y. And in this case, they are in the opposite phase. If this is 5 and this is 3, the resultant phase will be y will be y1 minus y2. They are in opposite phase. So 5 minus 3 will be 2. It will be like this, plus 2. This will be the resultant wave. We can see that for the same phase we have maximum amplitude, and for opposite phase we get the resultant minimum amplitude, the resultant of minimum amplitude. Okay. If the two waves are having same amplitude, if they are of equal amplitude, means 5 and 5, okay, same amplitude, then what do we get? The resultant will be 0 everywhere. This and this 0, this and this 0, okay, this will be the resultant. 0 amplitude every time, okay. Now let us consider a monochromatic source of light S. It is distributed into two sources by means of a double slit. Here we make two holes. The first hole is S1 and the second hole gives the source S2. Let us consider S1 produces a wave in such a way that the blue lines indicates it is the position of the maxima, and the red lines indicates it is the position of the minima, okay. Even for the source 2, blue lines indicates the position of maxima and the red lines indicates the position of minima. Maxima are peaks and minima are troughs. If we join the points where maximum and maximum, minimum and minimum meets, okay, or these points, if we draw a line passing through this, this will give the position of the maxima. This is the screen. And if we join the positions where the maxima and minima meet, okay, if we draw a line through this, this is the position of minima, okay. Again, maxima and minima, maxima, minima, maxima and minima, means blue and red meets at these points. Again, here, okay. Let me draw this as a green color. Here, maxima, minima, maxima, maxima, okay. If we join these points, it will be the position of maxima again. Here, maxima, maxima, minima, minima. It will give the position of another maxima. So, at the green positions, the resultant wave of the the intensity of the two waves gives resultant maxima here, and in these points, in the black points, the resultant of the wave is minimum, so the amplitude will be minimum at this point. It is destructive interference, destructive, and these points are called the position of constructive interference.